Kushi, do you want to share your, nice and loud, do you want to share your definition of a circle? Kate. Thank you. Would you like to share your definition of a circle with all of us?
Could I use the word round? But even if I don't, it doesn't really matter.
Who used the word round? Hands up. I think a lot of people use the word round, which, you know, I didn't say any words were off limits. Thank you, hands down. Did you use the word circular? A circle is a shape that is perfectly circular. That's okay, go ahead, just give us your definition.
A round shape with no corners, 4 quadrants, and a radius which is equal from the center to every point of its circumference.
Okay. Okay, so I'll come back to your definition in a second, but Ellen raises a great point, which is that, like, what is a radius? And the radius is a feature of a circle. Remember, this alien's never seen a circle before, right? So it starts to be like, wait, so what is this shape? Because you guys have known about circles for so long. There's such a common shape in the world that's like, well, I don't know what language to use. I like the definition, though. It's very, well, I'm going to come back to it. Ryan, was yours different?
Sure. Yeah.
Yeah, go ahead.
An object that follows one constant curve all the way around until it connects with itself again.
Wait, hold on. A constant curve that follows itself around until it what? Until it meets again?
Follows one constant curve.
One
all
constant
the way around
curve.
until it connects with itself.
What do you mean by constant?
As in the curve is going the same angle. Like.
Okay, all right. So you can see it's like we use words, but it's like, oh, we have all this meaning in there, which is like, but I don't know. Constant means a lot of different things, doesn't it? Because I was about to draw this. Like this, I mean, you know, that you get the idea. Like, yeah, do you like my? There you go. It's got some. It's sort of depending on what you understand constant to be. It's a curve. It follows it all the way around. It joins it anyway. Does anyone have one more stab? Yeah, Arif, go ahead.
Circle is a round shape that meets with its starting point. It has no corners, one edge, infinite axis of symmetry.
Okay. How many people said infinite axis of symmetry? Anyone? Yeah. Okay. Very good. Thank you. Hands down. Okay, I'm going to give you my definition, which, again, just like Ellen was pointing out before, all definitions are going to have some trouble because they're going to refer to ideas that it's like, well, but do you know what these are? So I've got a set of axes here. We're going to draw a circle on top of this. Underneath it, let's write rather, this definition, okay? A circle is, excuse me, the set of points and I'm going to use a fancy word here, which maybe you haven't seen before, but as soon as you see it, I think you'll know what it means. The word itself tells you what it means. The set of points, all equidistant from a central point. Okay? Now, this shares some of the characteristics of the definitions I saw around, but it's also quite different, isn't it? Did anyone talk about points at all? Did anyone use the word point in the different definition in any way? Yeah, a couple, okay. Yeah, I did hear it there. Equidistant, what does that mean? What do you think it means? Same distance. So in some ways, this is what Ryan was talking about, the constant curve, but this is just a slightly more fancy technical way of saying it. And you have to say it's all the same distance from somewhere, right? Which is the center, but maybe you don't know what the center is because you've never seen a circle before. So I said a central point. It's a point just like the others, but it's in the middle. Okay. Now, what I'd like you to do is put a Cartesian plane on top of your circle, right in the middle. Okay, so it's going to look something like this.
I don't know.
Your set square probably shuffled around the middle. It didn't quite stay. Oh. Hey, nice one. That was really good.
This is my scribble page.
Yeah, scribble pages are good. Arib, if a string is in a knot, patience will untie it. Patience can do lots of things. Have you ever tried it? Very nice. Very nice. Okay. How's yours look? Oh, of course you can. Of course you can. All right. Can I ask you now, regardless of whether you've drawn a circle or not, you'll have the rest of this lesson to go ahead and keep playing. Can I ask you to put your pens down and have a look up with me because we need to think together. And I don't know about you, I'm terrible at multitasking and the thinking and drawing at the same time, I think will go badly. So pop your pens down, out of your hands, set squares out of your hands, and I want you all to have your eyes fixed here, okay? That's still strictly speaking in your hand, so yeah, thank you, okay. So eventually you'll have something that looks somewhat like this. Your circle will probably actually look a bit better than mine. Mine's a bit potato-ish. I think that's the adjective of choice, right? Now here's what we're going to try and do. The 4 graphs that we had a look at this morning when we reviewed, right? They're all in terms of, they're not in terms of words like this. They're in terms of symbols, like this, right? So what we want to try and do is move toward an understanding of this shape that is not just this, but is also this. Now, how will we do it? Okay. So here is an example circle. I ask you all to draw the Cartesian plane so it's right in the center. Okay. So that means that this central point, you know where it is. What are the coordinates of the central point? 0, 0. Okay. So in a minute you're going to label that on, but I want you to be focused first. Okay. So pens should still be out of hands. Isabel, you too. Thank you. Now, not only do we know that, I'm going to do something a bit weird. I'm going to pick a random point on the circumference of the circle. And this really could be any point. Okay? So that means if it can be any point, I can't tell you the number of the coordinates, right? Because the numbers can change if it can really be any point. If only I had a branch of maths that deals with numbers when they can be different and they can change. Oh wait, it's algebra. So, here's what I'm going to do. Instead of naming the coordinates by a number, because the point is that the coordinates can change, I'm just going to call the x coordinate x, and I'm just going to call the y coordinate y. I really could call them anything I like. I could call them P and Q, or M and N, or Ryan and Steve, if I wanted to. But this way I know the x is an x and the y is a y.